Isotopes. As we've seen, atoms of the same element can have different numbers of neutrons. Of course, each unique element has its own specific amount of protons, but the neutron number can vary. For example, some carbon atoms have 6 neutrons, some have 8. Atoms of the same element that have differing numbers of neutrons are called isotopes. So here's two versions of carbon. They both have 6 protons. However, carbon-14 has 8 neutrons and carbon-12 has 6. They both have the same amount of electrons as protons. So just to summarize here in italics, isotopes of an element will always have the same number of protons but differing masses due to the differing numbers of neutrons. Write the complete symbol for each of these isotopes. Well, the first thing you notice, it's all neon, and neon always has 10 protons. So we can go ahead and write 10 in each one of these guys. It's the number of protons, that's the charge on neon. And also note that they have 10 electrons. The atomic mass is the sum of the neutrons and protons. So here we have 10 plus 10, approximately 20. Exactly 20. Here we have 10 plus 11. 21, and then over here 10 plus 12, 22. And you actually didn't even have to do the math if you didn't want to. Just look right over here. This gives you your atomic mass number. Not all isotopes are found in the same abundance in nature. For example, neon 20 is the most common form of neon found, and that's about 90.48% of all neon. Neon 21, 0.27% of all neon is neon 21, and then neon 22, 9.25%. So if you had 10,000 atoms of neon, you want on average, and again this is just average, it can certainly vary between different populations, there'll be 9,048 neon 20s, 27 neon 21s, and 925 atoms of neon 22. The atomic mass listed on the periodic table indicates the average atomic mass of all of the isotopes. So right here, so the weighted average for all of the neon isotopes is 20.18. The mass number indicates the exact relative mass of a particular isotope, so just one isotope. That is not reported here. This does not reflect 1 or 2 or 3 isotopes. It's the average of all of them. No single neon atom has this mass. To determine the atomic mass of an element, you need to know the masses of each isotope and how commonly they are found in nature. And then we're going to calculate a weighted average. So let's give an example. We've been working with neon. 3 stable isotopes, neon 20, neon 21, and neon 22. The relative abundance of them, as we've seen, is like so, just connecting them up here. How do you find the atomic mass of neon, which you put on the periodic table? Well, you multiply each isotope, see how the red here matches neon 20, neon 21, neon 22, by its percent abundance expressed as a decimal. So 90.48 will turn into 0.9048. This will be 0.0027. And then you just add all the products together. So here's neon 20 times its abundance, plus neon 21 times its abundance, and etc. here. And you put them all together and you get 20.18 atomic mass units. Here's an example. Let's work this one. Carbon consists of 2 isotopes that are stable, carbon-12 and carbon-13. Assuming that 98.89% of all of carbon in a sample are carbon-12 atoms, what is the atomic mass of carbon? So go ahead and try that. You can put this on pause if you'd like, and we'll pull the answer tab out in a second. Okay, you're back, or you never left. So the first thing to do is to find out the percentage of atoms that are carbon-13. Well, that would just be 100% minus this 98.89%, and you get 1.10% of all atoms are carbon-14. Then we go back to what we did on the previous slide. Here's your carbon-12 mass times its relative abundance expressed in decimal form, so that's 0.9889, plus the carbon-13 mass times 0.011, and we get an atomic mass here of 12.01 atomic mass units.